Great, and I'll start with grumbling about the time a little bit. I had to write this down because if any of you know me, you'll know that I'll babble for 2 hours, and I apparently don't have 2 hours. And so I guess this conference is about sustainability for agricultural production and water supply. Today we'll briefly explore ideas employed in western Nebraska to help us understand management of groundwater found there. This foundation will provide a platform for us to say just a couple of things about groundwater management and about sustainability in western Nebraska, and provide some insight into information gathering priorities that we should hold as we move forward. Since science is founded in observation, we as scientists attempt to be as objective as possible and refrain from making value judgments relating to particular policy approaches. Yet given relative expertise in some disciplines and unfamiliarity with others, we can't help but to carry some bias with us into each complex conundrum that we face. Today we'll consider a few ideas, some of which have some popular support, some of which maybe not so much, but we'll try to avoid flinging stuff at those ideas that we might not like. We'll explore western Nebraska through multiple parallel paths relating to groundwater use, its sustainability, and the physical system. We'll finish with a few things we know are beneficial, and hopefully we'll create a few questions. Idea number one is that we really need to vest ourselves in production agriculture, and that we should support that and industry, and so we would have no restrictions on groundwater pumping at all. So we could call this groundwater mining. So in terms of sustainability, is the mining method sustainable? Does anybody think that the mining method is sustainable? I do. Steve does, I think. There's two of us. I think it's sustainable. Primarily because it's nearly impossible to actually pump all of the groundwater. As we draw the water table lower and water becomes harder to get, the infrastructure needed to pump it gets more expensive. Some producers will convert to dry land or rangeland. Some producers will invest in infrastructure. Some producers will have deeper wells in deeper parts of the aquifer. As groundwater declines, some producers will fail. Behavior on the ground will adapt as the conditions change, and recharge still happens. So there'll always be some supply for the best producers with the best parcels. Understanding the physical framework of our groundwater system allows us to anticipate that changing availability. Though nobody in Nebraska has been intentionally mining groundwater, parts of western Nebraska with significant and persistent declines, the red areas in this map, are the best example that we have of this kind of management approach. These exist in Box Butte, Perkins, Dundee, and Chase counties. Even though the groundwater pumping in these areas is not completely unrestricted. So if we adapt idea one a little bit, we come to the concept that in CSD we sometimes hear from people, and even some water managers, the idea that if we restrict our groundwater pumping to only the amount of water that's naturally recharged, then we'll achieve a balance that will result in no ill effect. This is idea number two. We sometimes hear it called the safe yield or the water budget concept. So is the safe yield concept a sustainable method of groundwater management? Obviously, based on the logic we explained in idea number one, for those same reasons, it could be a sustainable way to manage groundwater. But does anybody perhaps believe we might have a few other problems associated with this approach? In Nebraska, management areas that utilize an allocation of specific amounts of groundwater to wells could be shown as an example of this type of approach, except that allocations in these areas have not been directly related to the volume of discharge or to the number and density of irrigation wells. Coheist estimates that the recharge in Pumpkin Creek is a fraction of an inch per year, while the allocations of a groundwater are around a foot a year. That's a big disparity. Now, we don't irrigate every acre of ground in the Pumpkin Creek watershed, so if we do the math, we may be close to that recharge level of pumping. What we do know in Pumpkin Creek is that in 2000 it was essentially dry. A traditional definition of the amount of groundwater pumping that would represent a safe yield is the volume of water that can be pumped, quote, regularly and permanently without dangerous depletion of the storage reservoir. Well, that's all wonderful, but what do we mean about regularly? What do we mean about permanently? Dangerous depletion? Feder, in his textbook on hydrogeology, calls the safe yield concept a paradox because of potential environmental harm, connection to natural discharge, imposition of legal and economic constraints, and the possibility of augmentation of recharge, which would actually increase the amount we could potentially pump. So fundamental to the concept that we know how much recharge there is in order to pump that amount of water, right? So how do we know what the recharge of an aquifer is? To date, there are very few techniques that provide a direct measure of groundwater recharge, of water entering that aquifer. And these aren't collected systematically and regularly across every basin. It's well understood among water scientists that a good proxy for the recharge of the system is the discharge of the system. And since we know that groundwater and surface water in Nebraska are connected, it's no surprise that this proxy is commonly used as a starting place in developing water management models. Steve and I are currently wrapping up a season of research which demonstrates through measurement the relationship between stream water and groundwater along the South Platte River, which shows both discharge from groundwater to surface water, the gradient values above zero in this chart, and recharge to groundwater, all the points that are below zero in this chart, at various times and locations along the South Platte River, at Big Springs, Paxton, and North Platte. You see that those are variable. So there are times when the groundwater is seeping into the stream along that reach, and there is also times when the stream water is seeping into the ground. Given this, in an overall kind of generalized water budget with recharge on the left and discharge on the right, it's worth pondering that if recharge is equal to discharge in the High Plains aquifer, what happens to discharge if we pump groundwater at the rate of recharge? Which brings us to idea number 3. The notion that pumping affects the discharge and that recharge and discharge will eventually balance. So we could define an arbitrary level of discharge, or stream flow in this case, desired and adjust our groundwater pumping accordingly based on this balance. We could call this the dynamic equilibrium concept. So is this management approach sustainable? Under this concept, we know that the aquifer system will balance and that our groundwater pumping is discharge, which can be accounted, and that previously existing discharge will be affected by the same magnitude as our groundwater pumping. This approach to groundwater management is sustainable because we're directly incorporating groundwater and surface water system relationships and are managing for the entire effect of our groundwater pumping. Are there problems with this approach? If our desire is to have no impact on stream discharge, then the amount of pumping that we can allow is simple. It's 0. That certainly won't sustain or even grow our agricultural production. If we step back a little bit and look broadly at estimates of our total groundwater pumping from the Groundwater Atlas of Nebraska, we see that Nebraska pumps about 8.5 million acre-feet of groundwater. If we maintain that level of pumping indefinitely, we'll eventually divert 8.5 million acre-feet of water from our natural discharge. This obviously represents a significant portion of our stream discharge if it's predominantly affecting that stream discharge. If 8.5 million acre-feet of discharge depletion affects primarily stream flow, our investments in surface water irrigation districts, which are incidentally a principal source of groundwater recharge augmentation, will not have a sustainable mode of operation either. Environmental flows will likely not be maintained, and downstream users, downstream appropriators, will likely see their water supplies interrupted much more frequently. Idea number 3 also ignores the time that it takes the High Plains Aquifer to respond to groundwater pumping. Studying this question gives us the indication that it could take centuries to millennia to fully perpetuate that effect. Since economic and sociological analysis are meaningless at those kind of time scales, we're not typically disposed to managing over those type of extended time frames. Even though we've actively manipulated water in Nebraska for more than a century already. Fundamentally, the 3 ideas discussed previously illustrate most of the primary considerations of groundwater management for agriculture production and the basic problems with each, yet they point at the beginning of a solution. You undoubtedly noticed that we asserted all of these approaches are sustainable. And you may have noticed that each of them may require varying levels of interest and involvement from different subsets of stakeholders. Since water issues are political and our various understandings or misunderstandings of terminology can be a hindrance to reaching common goals, we should begin by defining sustainability in an honest, transparent, and descriptive way. I personally prefer the term that we heard earlier today, the term desired future conditions, because that term forces us to think descriptively and use descriptive terminology to explain the various components of our water system and including our aquifer that we want to accomplish into the future. The lack of a clear and easily understandable definition of sustainability provides an easy opportunity for better informed parties to dominate the rest if we employ that classically Greek form of problem solving where we factionally debate and then take it in front of an arbiter. We should resist the temptation to marginalize or dominate potential stakeholders because they represent a smaller faction, a radical perspective, or a singular local interest. Similarly, we should seek solutions that empower local decision-making that has a better opportunity to be representative of factional consensus and resist the temptation to consolidate decision-making authority into a single entity, lest integrated water management in Nebraska become an example of Hardin's tragedy of the commons. One thing we can conclude based on recent history is that our inventory of interested stakeholders has grown, and that those interests are more diverse than ever before, indicating that a local, collaborative, and holistic approach to management is warranted and perhaps required to meet the needs of Nebraska and achieve a truly sustainable means of utilizing our water, remembering that if we don't use it, we cannot call it a natural resource. Science is founded in observations, and we as scientists attempt to refrain from making value judgments related to policy. Yet if we ponder that distinctly Western adage about whiskey and water, we intuitively know that the two should not, and maybe cannot, be separated. We hope and believe that the value of our technical analysis and scientific investigation can be magnified by the relationship between science and policy. I killed the room, Dan.
Pretty philosophical.
Dan handed out pillows. I told you not to do that.
Any questions for Doug? It's after lunch, I know. Oh, we got a question over here. Francisco?
Doug, you mentioned along the lines the issue of scale. And we deal with climate impacts, but we also deal with activities that are located at the field scale.
Yes.
The term sustainability, or the way that we should be addressing it, we are going to maintain the livelihood or improve the livelihood or the life level of life on the farm.
Mm-hmm.
Could be addressed to the current way that we are using the aquifer. Do we think that is sustainable? Do we need to change something? Is technology, what will allow us to improve?
Well,
Let's see if I can.
Basically,
go ahead.
No.
See if I guess the question kind of relates to, well, there's a question of scale, and how do we look at the system from various scales to understand what sustainability might mean to an individual producer? Is that a fair summary? I guess I think that is a kind of an unanswered question, and it goes a little bit. You saw the slide where Steve and I are doing stream groundwater interaction research on the South Platte River, and the point of that is that producers are doing wonderful things on the field scale. They're using a lot of equipment. They're managing water hourly, sometimes in real time, and then water managers are using broad scale models to manage at a reach, subbasin and reach, or even a watershed or a region scale. And those two things are a long ways apart. So we're making annual decisions or or big scale decisions at one kind of resolution and small scale decisions at the other. And that's kind of the point of our research in the South Platte River, is to ramp up from that field scale and aggregate up from that, as well as kind of telescope down from the reach scale in our measurements. I don't know that there's a good answer to that, except that the producer on the field with his butt in the seat, as Rourke said, will feel a lot better about regulations that he understands his connection to. And so I think that's kind of one of the big questions we face, is that one of scale.
Anyone else? Oh, we got one in the back.
Yeah. I'd like to know what percentage of recharge can be considered groundwater sustainable. How much percent of recharge constructed can be considered?
How much percent of recharge, what was the,
How much percent of recharge obstruction can be considered as groundwater?
how do you mean obstructed?
Because you mentioned because of your groundwater sustainable development, it goes with recharge.
I guess the point with recharge, we have a connected system, and before we imposed our stress on it, our diversion of of water from the stream flow, and our groundwater pumping and mining of that storage water in the short term, in the longer term, that groundwater pumping affects the discharge. So in a connected system, and the High Plains Aquifer in Nebraska is a connected system, basically everything that you pump is eventually going to perpetuate itself as a value. So sustainability is not really a technical definition that we can look for. There's no mathematical answer other than zero, really. If we want the system the way it was before humans impacted it, if you want to look at it that way, the answer to diversion is zero, the answer to pumping is zero. If our definition of sustainability is something else, it's really the definition of what level of consequence are we really willing to accept. And if we're going to mine groundwater storage, and every pumping well mines groundwater storage, at least initially, if we want to have some value of that, we can do that to the extent that we put it back. In Nebraska, that would be to the extent that the canals lose water, and the extent that maintaining high moisture levels in the soil permit additional rainfall recharge, and there's those extra recharge that wasn't in the system, in the groundwater system prior to that. So we can pump to the degree that we augment the recharge.
Okay, I think we probably have to move on to the next speaker.